Hi, this is Involved Innovation YouTube channel. In this video, we are going to explore the Model Context Protocol, MCP. There is a huge hype around MCP, so we will try to understand what is MCP. MCP, Model Context Protocol, is a standardized way for large language models to connect with external tools, databases, APIs, and applications. Before diving into MCP, let's quickly revisit what an LLM is. An LLM, or a large language model, is an AI system trained on massive data sets to understand and generate human-like text. LLMs power chatbots, assistants, content generation, and even code completion. The real challenge comes when you want your LLM to interact with real-world system. For example, if you want your model to connect to a banking system, you normally have to implement authentication and authorization flows by yourself, write actions for transactions, adding recipients, or checking balance. And also we need to write our own logic to fetch resources such as transaction history and then the recipient list. Similarly, if you want to persist the banking details in a postgres database by an AI tool, you have to repeat the process, handling authentication, writing CRUD operations, and ensuring secure access. This results in boilerplate, duplicated, and inconsistent code across projects. This is where MCP comes in. MCP addresses this by providing a standardized middleware layer. Instead of writing custom integration for every service, you connect to a MCP server. The bank provides an MCP server in this case that exposes tools for actions, example, making transaction, add recipient, and resources to access the data, example, to get the transaction history or to get the list of recipients. Similarly, a Postgres MCP server can expose tools to persist or retrieve data and resources to query structured information. This MCP server can be in your local or this can be in the cloud as well. You can able to access this MCP server directly from your chatbot to the server which is deployed in the cloud. With MCP, LLMs don't reinvent the wheel for every integration. They simply communicate via the MCP protocol, making development more consistent, scalable, and secure. Now we will see about the MCP architecture. MCP follows a client-server architecture. There are like three main components in MCP architecture. They are MCP host. The host is an AI application, example, Cloud VS Code, that manages one or more MCP clients. MCP client, the component that maintains a one-on-one connection with an MCP server. For example, if you want to establish a new connection with an MCP server, either that can be in your local or it can be in the cloud, this MCP client maintains one-on-one connection with that particular server. The next and the final and important one is MCP server. This is the server where we will get the tools, resources, prompts, data for the client. We will see these components with a very small example. Visual Studio Code can act as a MCP host. When it connects to a GitHub MCP server, it spawns an MCP client to maintain that connection. If it also connects to a local file system MCP server, it creates another MCP client. Each MCP client maintains a dedicated one-on-one relationship with that server. In the GitHub MCP server, it provides a lot of capabilities on tool side, accessing the repository, creating branch, and also on the actions. Primitives. The heart of MCP is its primitives. That is the building block for client-server interaction. So there are like three main primitives, and then there is additional two: resource template and sampling. We will see each with a very simple example. Let's take resource. Structured data that provides context. For example, here if you are creating a Notes application or Notes MCP server, then notes all will return all the notes. So this provides context to your LLM. So your LLM will work on this data and it can able to fine tune it, it can able to get more context around it, and it can able to even summarize on it. So your LLM can really get the context from the resource. The tool, it is one of the very critical primitive which exposes an action that an LLM can trigger. For example, if you want to create a note and that create note can able to process the detail in your data store, this tool exposes that capability so that AI can able to make use of this capability. For example, in GitHub world, if you want to create a branch, you can simply use the tool exposed by the GitHub MCP server. And then prompt, it's a reusable predefined instructions for the model. Let's take if you want to create a complex prompt, that prompt needs few more context from your MCP server, then it can get that context. For example, if you want to get a resource from a database and then if you want to summarize on top of it, and then if you want to fine tune and then you want to come up with a prompt for that so that you can able to query that back to the LLM. Now there are additional two things which is also used widely. They are resource template. This is for parameterized resource patterns. For example, if you want to get only a particular nodes from the list of nodes, you can able to fetch with the nodes ID. Sampling, this lets AI generate or refine content dynamically. So this will help your MCP to connect to your LLM. The MCP will send a prompt to the LLM model and then it will get the answer from there and then it can able to refine content dynamically. So this is sampling. So these 5 are the basic primitives in MCP architecture. So first we will see about what happens if you are not using MCP. So custom integration. Without MCP, you will need to make your custom integration. Let's say you want your AI to talk to your bank and also to a postgres database. Without MCP, you need to write custom code for each service. One API client for the bank, another one for the database. Each service has its own rules, so you end up writing different integration code over and over again, and then this need to be repeated for each and every project as well. Authentication handling. Your bank might use OAuth, your database might use username and password, basic auth, and another API might use an API key. Without MCP, you need to handle all this separately and securely. That means extra code every single time, and also this comes with a security risk. Want to transfer money from your bank account? You write a custom function for that. Want to save those details in Postgres? Another custom function. Every action you want AI to perform requires a new code. None of it is reusable. Let's take you are using a very complex tool like GitHub. This already has lot of actions to perform. Then you need to really write code for all these logics. If you want your AI to fetch your last 10 transactions from the bank, you need to manually code that API call if you want the last 10 nodes from your database. You can code a different function, the logic is similar, but since the services are different, you repeat the word. Repetition. So everything whatever we have discussed now mainly concerned about repetition and manually doing it. So every time you start a new project, you end up rewriting the same things, authentication, actions, fetching data. It feels like a deja vu, same problems, slightly different code. Inconsistency, because of each service is integrated differently, your code base becomes inconsistent. If you are trying to access the Postgres in 2 different applications, there is a possibility that in 2 different applications you can be having 2 different code base, and then that follows different paradigm. The way you log errors for the bank might not match how you log error for the database. Over time, this makes your project harder to maintain and scale. With MCP, this all issues are like mitigated. Standardized middlewares. With MCP, all services follow the same format. Whether your AI is talking to the bank, a database, or GitHub, a communication looks the same. It is like using one universal adapter for all devices. Uniform authentication. Instead of writing separate authentication for each service, MCP handles it in a standardized way at the transport layer. For example, whether it is a OAuth for your bank or an API key for GitHub, MCP makes it consistent for your AI. Tools and resources. Services expose their capabilities through tools. And then resources, the data which we will be feeding to the LLM. For example, bank MCP server, it can able to provide tools such as make transaction, resources transactions, and resend. Postgres, similarly, it can able to provide tools like insert note, resources such as notes all, which will return all the notes. Your AI calls this in the same way no matter the service, because these are all exposed as the capabilities provided by this MCP server. So whenever MCP server comes in, your AI LLM can able to read what are the different capabilities it provides. It can able to go through the different tools, resources, and then AI can able to make a decision which tool can able to call. For example, if I am providing a prompt such as create a note with this title and then this content, then here AI will understand for this prompt I need to call this tool create note with all these params. Reusability. One MCP client can connect to multiple servers. That means your AI can talk to your bank, your postgres, or even your local system, all in same session. No need to build custom connector for each. Reduced boilerplate. Obviously this all reduces the boilerplate which we are gonna write, and instead of writing CRUD operations for every new service, you just use what the MCP server exposes. For example, you don't need to write SQL queries manually. The MCP server already gives you the tools. Want to add GitHub integrations later? Just connect to the GitHub MCP server. No need to rewrite your core logic. It plugs right in. And then if you want to just remove any of the MCP server, then you can just remove that integration. It will be seamless. MCP works both locally using standard IO and then remote through streamable. Locally, it can use standard input output for fast communication like between your AI and local process. Remotely, it can use streamable HTTP, which makes it easy to connect to cloud services securely. Now we will see about MCP layers. MCP is built in layers. Each layer has a specific job. Let's see what are the different layers. Data layer. The data layer defines how the information is structured and exchanged between the LLM and the service. It uses JSON RPC, which is a lightweight way to send requests and responses in JSON format. If you want to understand more about RPC, remote procedure call, I have a video on remote procedure call. You can find that video in my channel. Think this JSON RPC more like a grammar for a conversation. Example, if your AI wants to create a note, it sends a JSON request like this. It will have properties such as method, the method create note, and then params, what are the different params this create note method takes, and then the server replies back with another JSON response confirming the note was created. This layer also defines the core primitives like tools, resources, prompts, and the notifications, basically the vocabulary that AI can use. The next important layer is the transport layer. The transport layer is about how data actually travels between the client and then the server. MCP supports two transport mechanism. One is standard input output transport, which uses standard input output streams, the same thing you use when running programs in a terminal. For example, if you run MCP server on your local machine, which we will see later in this video, your AI can talk to it directly using standard input output. This is super fast because it is just two processes on the same machine exchanging text, no internet required. Next is streamable HTTP transport. Let's take if your MCP server is deployed in the cloud. This uses HTTP post for sending request and server send events to stream response back. Example, if your AI connects to a remote bank server or a remote GitHub server over the internet, it might send a transaction request using HTTP, and then the server streams back updates like transaction started, transaction complete. It also supports authentication methods like OAuth, API keys, or custom headers, so it is secure enough for production use. Now we will create a new application. In this we will create a practical case. Notes MCP servers connected to a Postgres database. We will use Docker in this case so that you can able to follow along with me. And then we will create primitives such as tools, here we will create a tool to create a new note, and then resource to fetch all notes from the database, and then resource template receives a specific note by ID, and then prompt suggests the content based on the given title. So it will give back as a prompt based on the title which we provide, and then sampling auto generated note body from the user provided text. And we also see about MCP client, which connects to this MCP server. First we will start with the essential setup. So for that, first we will create a Docker compose file. So this Docker compose file, we will create a Postgres database, and also we will create a pgadmin tool. You can find all this code in my GitHub repository, the link of which I have provided in the description. I will copy and paste the Docker compose file. So this has services such as DB. So the DB is Postgres, and then it also has pgadmin to access the DB. So we will save this. We will give the file name as docker compose docker-compose.yaml. Here we have created. We will open the terminal here and then enter the command docker compose up-d. This -d will help us run this docker compose in detached mode, so that if you stop this terminal, the docker will be still in running mode. It created the container. Now if I open my Docker desktop, I can able to see two different containers are running in the Docker, and one is Postgres and then one is pgadmin. Now I can able to go inside the localhost 5050. So this is where our pgadmin is running. Enter the username admin@admin.com and then the password as admin. So this is the username and password which we have set in the Docker compose file. You can able to find this here, and you can able to modify this here if you want. Now we have our pgadmin running. Now we will create a new server. So click server, and here I will name this as notes, and then select servers here, and then the connection give DB, because this is a service name which we have provided for our Postgres. Since both are running inside Docker and we have connected both this internally, we can able to connect this pgadmin to our Postgres database which is running in the Docker by just giving the DB here, and then port is 5432, and then maintenance database is Postgres, and then username is admin, and then password is admin. So now we can create this. Now we will create our database. So create database. Here enter notes, and then the owner is admin. Now we have created it, and then open the query tool here. Now we can create a table, and then the table is notes table, and the notes table has notes ID, title, content, tags, and then create date and due date. Run this. Now we can able to see we have successfully created the table. So we have our prerequisite done. Now we will start with our MCP server. So we will go and we will use the UV here. So install UV, go to terminal and enter this PowerShell -execution policy. You can able to find this in my GitHub repository, and this will install the UV. We can able to create the project here. Go back to the MCP server here and open the terminal in this part, and then create a UV in its nodes. So we have created a new project named nodes, and then here we will create a virtual environment, and then we will activate that virtual environment as well. Go inside the nodes folder and then create a virtual environment UVVENV. Open the Visual Studio Code and we can activate that as well. So open the Visual Studio Code in this particular folder. Now we have opened the Visual Studio Code here. Open the terminal, and here it is automatically activated. So if it is activated, you can able to see your folder name inside the braces that will be appearing in the front. So that means this environment is already activated. First we will create a tool. I already did this, so I will copy the code and then I will paste it here, and then I will try to explain. So open the main.python. So this is where our code will go. So here replace this code piece. So you can able to find this code in the GitHub as well. This needs dependencies such as MCP and then driver for the Postgres. UV add. So this is the way you can able to add the dependencies here. Once you are added, you can able to find this dependencies gets added in the PyProject TOML. Here we have added this dependency. We can able to see this file gets updated with this two dependency. First we will start with the MCP. So here we will create a fast MCP and then we will define this as notes, and then we will start with the logging. So since we are gonna use the standard input output, we can't use the standard input output to print our logs. So we need to have a logging framework. So in this case, I am using this logging framework, and then I am providing this way so that the logs will be always persisted. So this will help us in debugging. So all this logs will go inside this particular folder, and also it will go inside this notes mcp.log. And then we will create our first tool. So to create a tool, you need to use this decoration at mcp.tool, and then you can provide your description. So here this description is, this will create a note with title, content, tags, and then the due date. So the arguments list are title, this is the title of the note, and then you have the content, this is the content or body of the note, and then the list of tags for that particular note, and then due date in ISO format. This can be none as well. And then this will return a confirmation message whether the notes created successfully or not. First, we will just try to log the message here, and then we will try to connect to the notes database which we have already created. So this is running in your Docker environment. The DB name is notes, username is admin, and then the password is admin, and the host is your local, so it is localhost, so it is 127.0.01, and then the port is 5432. And then here in the logging, we will just log a message again there just to make sure your connection is fine. After that, we will create a note JSON with the input params, and then we will persist this detail using the insert query, and then we will stop the connection, and then we will be sending this as notes created. And then in the main, we will try to run this. So this is where I am providing the transport. Here the transport is standard input output. Now we have our basic MCP server with a single tool running. Now we will see how to run an inspector. So to run an inspector, you need to run this command npx at model context protocol /inspector uv run main.py. Yes, okay, to proceed. Now we can able to see it created a MCP inspector. This is also running in my local in 6274. Now I can able to connect to my MCP server. So this is my Notes MCP server. If I click connect, so this is failing. We'll go back and we will try to see what is our problem. So here the problem is we have our notes.mcp stored under the temp folder. Here there is no temp folder. So we need to create a temp folder here, temp folder, and then stop the inspector, and then start the inspector again. Now this will open the inspector. Now it should work fine without any issue. Now click connect. Once you click connect, you can able to see it connected to the Notes MCP server. So here we are using the transport type as standard input and output because this is in your local we are connecting. So here we can able to click the list resources. We should not see anything here because our MCP server currently doesn't have any resources. So go to the tools tab and click list tools. Yes, we can able to see the nodes here. Now we can able to create nodes here as well. So for this here I will create the node as learn system design, learn about scaling, proxy. You can add items such as learn, add item, and this is fine. And then the due date can be any date. So here I'm not providing any due date, and then I'm clicking run. So here it says the invalid timestamp for date. So I'm just providing some date here, 2025. Now run tool, I can able to see the learn system design got created successfully. And if I go back to the pgadmin, and here if I select start from nodes, learn system design, perfect, the inspector created a node. Now we will try to see how we can able to integrate this tool to our Visual Studio Code. If you integrate this MCP with your Visual Studio Code, then you can able to call the MCP server from your Visual Studio Code itself. So enter Control Shift P here, search MCP and click add server, and then here it is standard input output because this is local. So here you need to provide the command, and the command is uv. You need to provide the directory as well, and we will name this as notes server, and we will make this as workspace trust. Now this is perfect. Now we have everything here, and we can able to find the mcp.json here as well, and this mcp.json is only applicable to this resource. Change this ask to agent mode. So here this is code, is not learn trust, and then now it is in running mode. You can stop and then you can start it. Now it is running perfectly fine without any issue. If you provide hash, so the create nodes is there, so I can able to call this create nodes, enter a prompt, create nodes with the title learn MCP and the relevant content, tags as AI, MCP, LLM, and due date as 5 dates from today. And this is using GPT-4o as the LLM. Run it here. Now you can able to see this is the JSON it is going to persist. So it is asking us the permission. Yes, this is going to use the tool create nodes which we have created. That is also perfectly fine. And click continue. Now we can able to see the node title learn MCP created fine. So all this we have achieved just in the Visual Studio Code itself. Now we can able to give any prompt, and then it can able to work fine perfectly. So now go back pgadmin, where you can able to find learn MCP as one of the entry. Yes, that is perfect, which we have created from the Visual Studio Code. Now you no longer need to just provide the hash create nodes. You can provide a prompt like this. Here I am providing a prompt like create a node with title grocery and relevant content, tags as shopping weekly, and due date as 2 days from today. So now if I click this, yes, perfect. Here I am not providing any hash create nodes like I have provided it. This is just a plain text. It's more like a prompt. And here also I'm saying like create a relevant content. So it created content. This is node for planning and organizing the weekly grocery shopping. It automatically created for us. This content is coming from the LLM. And then weekly shopping weekly, and the due date it automatically created 2 days from today, which is September 7. Perfect. Now a new node got created as well. So we have successfully created a tool. So this is what I have said when we are in the theoretical section, that is like the tools will be utilized by the AI and it automatically calls based on the prompt. Now we will create a MCP resource. So the MCP resource, as I mentioned, this provides the context to the LLM. So for this, I already created that method as well. For this, we need to use the annotation at MCP resource. Here I'm trying to get all the nodes, so I'm just giving get all, and then the description is retrieve all nodes from the database as a JSON. So this gets all the nodes from the database and return it as JSON. So it is good to note all these things as a description here, so that your AI can able to understand from this context. So here return us all nodes as a JSON array. So here we are trying to connect to our Postgres database, and then here we are using select star from nodes, and then we are retrieving everything, and then we are converting it to a JSON. So now we will save this, and then we will go to the terminal. Here we will stop this, and then we will start this again. Now once I start this again, now a new inspector will open, and then I can connect to this now I can connect to the MCP server. Now I know I have one of the tool, that is create tool, which we have created. And now if I click list resources, I can able to see the get nodes is there. So if I click get nodes, it says error because the dictionary cursor is not created. That is perfect. So here I need to import the dictionary cursor. So save this, stop the inspector, and start it again. You should see inspectors running. Perfect. And then here click connect. Now click list resources, and once you click get notes, yes, we can able to see the notes, whatever we can able to find, like learn system design, and then it also has learn MCP, and then the glossary, whatever you have in the database, we can able to retrieve from here. Now go to mcp.json, restart this. So if you restart, this will be the one which is providing the context to your Visual Studio Code. And to access this, select MCP resources and then select get notes. Yes, now you can able to ask questions on this particular context. Here I will ask get all notes. So if I ask get all notes, you can able to find it has 3 different notes. It has learn system design, learn MCP, glossary. All this we can able to get from the Visual Studio Code. So how this works is this connects to our MCP server, and from our MCP server we are getting these resources back. And now we will create resource template. So this is quite similar to resource, but here we can able to provide the additional param so that we can able to get a particular data from the resource. We also need to use the same annotation at MCP resource annotation. So here in the resource template, we will be passing in the param. So here the param is title, and then we will be establishing the connection with our Postgres database. And then here we have our select query. So here we are passing in our title, and then we can able to get the JSON data. If there is no data found, then we will be just simply throwing error. So now this is fine. Now we will restart the inspector. Now the inspector got opened. Connect to this inspector. So this connects to our node server. Now we can able to find the get nodes. Perfect. And then the tools, we can able to list all the tools. Perfect. And if I list the template, yes, we can able to find get node. I can enter something like glossary and then read resource. So now if I click glossary and read resource, we can able to retrieve that one particular node only. So same, we will go and restart the MCP JSON. Perfect. And click add context and select MCP resource. Here get node, and here I will need to provide the input, and now I have the context set. So get this node content. So this is node, and by when I need to complete this node. So here I can able to provide the questions here. That means if I am asking by when I need to complete this node, it says September 7 because that is due date, and then the content, I can able to get the content out of it. So now we have saw about like how to create resource tool and resource template. Now we will see how to create a sampling. So this is one of the interesting thing. The sampling can able to send question back to your LLM, and then LLM can able to give the answer, and then this will be executed again. We will see this with example. So here for sampling also we will be using at MCP tool decorator, and this is generate node, and then here generate a node for the title. So here we will be using the prompt. So this prompt will be sent back to your LLM. So in this case, this will be sent to a GPT-4 because this is running in Visual Studio Code. Here I'm using this particular model, and then this will give result for this particular prompt. So this LLM will give a result to this particular prompt, and then with that result, it will execute this create node. So what happens here is return only JSON with the properties title, content tags, and due date with generated content and tags for this title. So I am entering the title here. So this title is input param. So this input param, it gets and it creates content tags, due date with the generated content tags for this title, and then it calls the tool which we have already defined here, and then it creates the node here. So now we will execute this. Go back to the terminal, stop this and start this. MCP also we will restart and go back to the inspector, connect here and here. So it will be visible in the tool. So here we have our generator node as one of the tool here. Now this is perfect. generate note, enter, and then here it takes as a particular title. I can change this title. So this says this is the JSON RPC which we have talked about, right? So your host says that this is what I am gonna send to our MCP server. Are you fine? So I am not fine with this. I am gonna change this title here. So here instead of generated note, I will keep something like book flights. So here when I click continue, it says here the MCP server node server issued a request to make a language model call. So that means our MCP server is trying to access our language model call, and do you want to make request during this call? Yes, allow in this. Then what happens here is this particular prompt will be given back from this MCP server. It will get the data and then it will be persisted here. I can able to see book flights for conference to Chicago, and then it says the different context, and it all created by the LLM, and then it created the tag, and then it also created create date, and then it doesn't create any due date because we didn't provide any due date. This is perfect. So now we have created our sampling. So now we are almost done. The final piece is prompt. So prompt will help us get a prompt back so that we can able to call our LLM with that prompt. So here in this case, I will make this really simple. For this, I will use the decorator at mcp.prompt. This is to generate a content prompt. So for this, here I am just giving the prompt as please write a relevant node content for the title. And then I will go restart my MCP server so that now the Visual Studio Code has the latest one. Similarly, I will stop this and then I will restart the inspector. This is perfect. Now go back to connect and then go to prompts, list prompts. Yes, I can able to find the relevant content here, and then enter the title here. Go fishing, get prompt. So it gave us a prompt, please write a relevant content node for the go fishing. So that is here we need to provide title. For the title, go fishing. So now if I refresh this terminal and then restart the MCP 1 and then connect and then go to prompt, list prompt, and then select the prompt here, go fishing, and then get prompt. So now in the content I can able to find please write a relevant node content for the title, go fishing. Perfect. So similarly we will try to execute the same. You can able to see one prompt is there. So slash MCP node server relevant content, and it asks for the title here, go fishing, and then it automatically have our prompt. So now I can enter this and your LLM can able to give the content here. So this is note about planning a fish trip, including selecting the location, gathering necessary equipment, and checking weather condition to ensure a successful and enjoyable experience. So now we have created a complete MCP server with all the 5 primitives, which also included the resource template and then the sampling. Now we will try to create MCP client. As per our architecture, this MCP client we will try to use a LLM, and for this I am going to use the OpenAI API key, and then I will try to use that LLM to connect to this MCP server. We will go back to the folder, and here inside this I will open a terminal again, and then I will name this as UV init nodes client and then cd nodes client. And then here we will create a virtual environment. So UV VNV, and we have created a virtual environment here. We will open this in the Visual Studio Code. This is now in the Visual Studio Code. Now we will install all the dependencies. Since this is going to use our MCP server, we also install the dependencies, whatever we have defined there. So now we have installed the dependencies. Now we already activated the environment, so this is already there in the environment. We will create a env file here, .env, And here in this VNV, we will add the OpenAI API key and then OpenAI model as well. So this OpenAI API key you need to get from your OpenAI subscription. You need to pay for this, so you can use different models as well. You can either use Claude, you can either use any other model. So this is my personal OpenAI API key. Here, just for the convention, I will rename this to client.py, and I already created a code for this, so I will copy and paste this, and I will try to explain the same like how we have done for the server as well. We have our MCP client. First we will define the OpenAI model. So for this I am using ChatGPT 4.0 mini model. So this is what I am providing here as well. So I can make this as mini. Here I am getting the OpenAI API key from the .env file, and then I am defining the session and then OpenAI model, and then here I am trying to connect to the server. So here I need to pass the file. So I will show how we are passing the file. So in this case I need to pass my main.py, so that is our server, because this is all connected through the local standard input output JSON RPC, so that calls the function directly whichever there in the main.python file, and then we will be using the server params, and then we will use the standard input output as our transport, because that is the transport mechanism which we have used there as well. And then we will connect to our MCP server, we will create a session, and then here we will create a method to get all the MCP tools. So it gets all the MCP tools available in that particular MCP server. So this method gives me details, what are the different details it has, and then it creates as a JSON. So it gives types, functions, names, and then it gives the tool name, and then it also gets the description parameters, and then each parameter what are the different types and properties. And then this is where our processing query takes place. So here we are processing our query, so that means we will be using the OpenAI API key. Here we are first getting the MCP tools, and then here we are sending the tools to our OpenAI, and then here we are getting the message, choices message. So here we are appending the tools to your OpenAI, and then we can able to use that MCP server from this OpenAI to clean up stack. We have our main function. So first we have created an instance of MCP client, and then here we will connect to our main.python. So this is there in code. So in your case you need to update this to your folder or this to your file. So this is living in learning code MCP, and the notes main.py. This is the prompt which you will be sending to your OpenAI, and then from there it will create. So now can you create a new note with the title learn MCP? So learn MCP is already there. So instead of learn MCP, by meter saw to make angle cuts would work, learning and hobby. Perfect. Now here we have our prompt. So here it says, can you create a new node with the title by meter saw with the content as meter saw to make angle cuts, tags as woodwork extra. Now what happens is this MCP client makes this call, and this already has the tools, because here we are getting the list of tools and we are feeding that to our OpenAI, and then it will call that MCP and it will get a new node with this by meter saw created. So now we'll go back and check whether there is anything like by meter saw is already there or not. Should not be there. Okay, nothing is there, only we can able to see 4 entries. Now we will start the client. So here enter the command python client.py. So it already has this main.py path. You can also include that as one of the command line arguments, and then it will try to get this code, and then it will use the JSON RPC to connect to this main Python. It will create a new session, and then from there on it will try to connect with the OpenAI. So now if I run Python client, so the query is, can you create a new node with the title by meter saw with the content as everything perfect, and the new node title by meter saw successfully created with the content meter saw make angle cuts perfect. Now go back to database, and now you can able to see by methods are successfully created. In this video, we have seen how to create an MCP client and how we will integrate your Visual Studio Code with your local MCP. So this is the same way you can able to connect to our MCP server, which is hosted in the cloud as well. And then we also saw about the different primitives, and we in the MCP server we have created MCP server for notes connecting to the postgres database, and we saw complete the MCP. Thanks a lot for watching this video. For more technical videos, subscribe to this channel. For learning more about the AI, subscribe to this channel. I'll be posting a lot of videos on the AI and system design. If you like this content, share it with your friends.